Hi, everybody. This is Brian, and I'd like to present my third and final presentation around human factors in AI. For my problem, I chose to pick the same problem space as I presented for Course Two's final course project. It's all around electric vehicles, or EVs. And the core problem that I wanted to focus on was how do we make sure that our power grid keeps up with the explosive demand of EVs through machine learning? There's a link on the screen where you can watch my Course 2 presentation in case you're interested. But the problem statement was as follows. How might we leverage machine learning to optimize electric vehicle charging at scale without creating a significant impact on our energy grid? Jumping into the content for this course, I first conducted a task analysis looking at what I consider to be the most important key task: charging your electric vehicle at the most important appropriate time. There are other tasks that aren't covered here, such as configuring a user profile or canceling or pausing charging or even reporting feedback to the system. But this was, I thought, was the most important. And you can see this flow chart that I created from this. The trigger would be, hey, you're an EV owner and you've returned to your home or to a common office complex or something, and you want to figure out for the next day, how much charge do I need in order to have enough power in my car to go to where I need to go? And also, in a way to minimize the impact on my wallet and on the efficiency of our electric grid that powers my EV along with millions of others. There are three key decision points here. First, does my EV have enough charge? Second, what is the amount of new charge needed? And third, when should I start charging my car before I need to head to work tomorrow in order to have enough time? And really what occurred to me is that those later two decision points, the amount of new charge needed and the correct time to begin charging, can be automated using machine learning. So that leads us to the solution. I proposed in Course 2 a machine learning powered app that's connected to your smart EV charging device, which could help you schedule the charge activity at the right time to give you enough juice for the next day. And here's a simple prototype that I developed of the user interface for this. From the concerns with privacy, we would need to collect some user information into their profile, such as their name, their email, and their home and work locations, potentially even additional locations that could help the system determine when they need to start charging. So let's look at what that might look like. So this is the machine learning powered view, which once it has enough data, would allow the system to predict and schedule a specific time when the charging should begin after it's plugged in. Once the charging is done, you can see that the system has a simple way of providing feedback from the user for whether the charge that was recommended by the app gave you enough juice for the next day. And there would be a help area to explain how the data is collected and used, any privacy implications. For the cold start problem, where we don't have enough data yet to predict, there's also a path where the user can specify their home and work addresses and potentially other locations. And the system would then do the same thing, where it would manually assign a start and end time. And the user could configure these as well if for some reason they weren't happy with this behavior. And the result would be the same. The car is charged, hopefully with enough charge, and it's done in a way that doesn't impact peak hours of the electric grid. Now let's look at some privacy considerations. Well, we are collecting some data which might potentially be used or useful in tracking where a user travels each day. So that is potentially sensitive information, as well as the location of the charger, such as a local home address. And since we would sell this app in both the European Union and in states such as California, those privacy laws, such as GDPR, would apply to this app And really, with the fairness practices, it's all about connecting the minimum amount of data, only storing it as long as needed, and having appropriate data security and opt-out procedures in case users aren't happy with this. In terms of ethical considerations, the biggest bias or source of bias that I could see is how this model is trained with the test group. We'd have to put special care into having a set of test cases that is representative of a wide range of households, commute patterns, occupations, and demographics. There's also the case for learning bias and feedback bias, although I don't think that those would be as strong as the potential for representation bias. And finally, I wanted to end with the three goals of ethical AI and how this solution would meet those goals: fairness, accountability, and transparency. With fairness, it's all about ensuring that people who are in similar demographics receive similar outcomes, and we could conduct fairness auditing after the release in order to continue making sure that we're presenting a fair solution. On accountability, well, they could always charge manually if they don't want to use this app, they don't need to install it. But then there would also be a recourse through the feedback mechanism for users to say, hey, this model didn't work for me. And on the transparency side, you saw the callouts to the help and explaining the model and the solution mockups. But what we would look to do is really explain in real language how the model is calculating the approximate charge levels and tie it in with that feedback mechanism. So with that, I wanted to wrap it up. Thank you so much for your time.